Somewhere in the deep ancient dark, the James Webb Space Telescope found something that should not be there. Not a planet, not a star. Something that breaks the rules we thought governed the universe. At first, scientists assumed it was an error, a glitch in the data, a trick of distant light. But the more they looked, the more impossible it became. This is not science fiction. This is happening right now, in observatories across the world. And nobody, not one expert, can fully explain what they are looking at. To understand why this discovery is so unsettling, we need to go back to what Webb was built to do. It was designed to look further back in time than any instrument before it. Webb captures light that has traveled for over 13 billion years across the cosmos. That light is a fossil, a frozen snapshot of the universe in its infancy. Astronomers expected to see small, faint, newborn galaxies in that ancient light, simple structures just beginning to form after the Big Bang. Instead, they found something massive, bright, and fully formed far too early. A structure that, by every existing model, simply should not exist yet. Imagine finding a fully grown adult in a hospital nursery meant only for newborns. That is roughly the scale of the contradiction scientists are now confronting. The object, glowing faintly red across unimaginable distance, defies the timeline of galaxy formation. Current theory says galaxies need hundreds of millions of years to grow this large. But this one appears to have formed in a fraction of that time. Either our understanding of the early universe is wrong, or something else is going on. When the data was first confirmed, researchers reportedly sat in stunned silence. One scientist described the feeling as watching the rulebook of cosmology quietly fall apart. Peer review followed, then disbelief, then a wave of competing explanations. None of them so far have managed to fully solve the mystery. The first theory suggests early black holes grew far faster than anyone predicted. If true, this would rewrite how galaxies and black holes evolved together. A second theory proposes our models of dark matter may be incomplete. Dark matter clumps before normal matter, acting as cosmic scaffolding for galaxies to form. If that scaffolding behaved differently in the early universe, growth could accelerate dramatically. This would mean our entire cosmic timeline needs a serious rewrite. A third, more radical idea involves the nature of light itself across vast distances. Some scientists wonder if redshift, our main tool for measuring cosmic time, hides flaws. If redshift calculations are even slightly off, ages and distances could be miscalculated. This would not break physics, but it would force a humbling correction. None of these explanations are confirmed, and scientists are careful to say so. Extraordinary claims, they remind us, require extraordinary evidence before acceptance. Still, the unease is real, because this is not an isolated case. Webb has found several of these strange, overly mature early objects already. Astronomers have started calling them universe breakers, half joking, half serious. Each new detection adds pressure to a model that has worked for decades. The standard cosmological model, called Lambda CDM, has explained the universe remarkably well until now. It predicted the cosmic microwave background, galaxy distribution, and expansion with stunning accuracy. But models are only as strong as the observations that support them. When new data refuses to fit, scientists must decide what to question. Do we question our telescopes, our equations, or the universe's actual history? This single decision could reshape physics textbooks for the next generation. Some researchers believe we are witnessing the birth of a new cosmology, a shift as significant as when Einstein challenged Newton over a century ago. Others urge caution, reminding us that science often finds quieter, simpler answers. Instrument calibration, dust interference, or rare cosmic coincidences could still explain the anomaly. Yet even skeptics admit something genuinely strange is hiding in this data. The object refuses to behave like anything we have cataloged before. As more data arrives, scientists are racing to confirm or rule out each theory. Every new observation either strengthens the mystery or quietly chips away at it. What makes this moment so thrilling is its raw uncertainty, unfolding in real time. We are not reading about a finished discovery, we are watching one happen. Telescopes like Webb were built to answer old questions about how galaxies form. Instead, They may be revealing how much we still do not understand. Every great leap in science begins exactly like this, with confusion and disbelief. Copernicus, Einstein, and Hubble all faced data that broke their era's assumptions. Perhaps this glowing, impossible object is not an error at all. Perhaps it is the universe quietly correcting our confidence in its simplicity. Somewhere out there, light older than our planet is still arriving, carrying secrets, and we are only beginning to learn how to read them. What if the early universe was never as slow and gradual as we assumed? What if structure, complexity, and light emerged faster than any model predicted? For now, the answer remains hidden behind billions of light years of silence. But Webb keeps watching, and somewhere in that data, the truth is waiting. Maybe the universe is not broken. Maybe our understanding simply has not caught up. And maybe that gap, however unsettling, is exactly where discovery begins. If this glimpse into the impossible fascinated you, there is so much more to explore. Subscribe now and join us as we chase the universe's next great mystery. Thanks for watching. See you in the next one.